In this video, we will determine the sum of the first n natural numbers, and a natural number is a positive integer. It's a whole number, and you can kind of think like 1, 2, 3, 4, so on. And this is one problem that we will go over together, and it's a very famous problem. It's 1 plus 2 plus 3 plus 4, so on, until you have plus 100. And so if you want to pause the video here and attempt this problem, feel free. This particular problem is a very famous problem, and the mathematician Carl Gauss is often credited with it, and there's a pretty cool story behind it if you're interested in checking it out. So if we have 1 plus 2 plus 3 plus 4 plus 5 and so on, it continues until you have plus n. And so there's a nice little trick to determine the sum of this. And so what we do is say this: sum is equal to 1 plus 2 plus 3 plus ... plus. Now at this point, I'm going farther in the list. So like the very last three numbers. So I'd have n minus 2 plus n minus 1 plus n. And now I do the reverse. I go backwards. I go from the top n, then I go n minus 1, then n minus 2. And so these are the three biggest terms, plus ... plus the smallest three terms, 3 plus 2 plus 1. Now what if I sum these two pieces, I sum these two pieces, I sum these two pieces, these two pieces, these two pieces, these two pieces, and these two pieces, and see what happens. And so we would get 2s is equal to 1 plus n plus parentheses 2 plus n minus 1 plus parentheses 3 plus n minus 2 plus ... plus n minus 2 plus 3 plus parentheses n minus 1 plus 2 plus parentheses n plus 1. And so if you notice, this is n plus 1, this is n plus 1, this is n plus 1, and so are the other three terms. They're all n plus 1. And now if we divide by 2, we can say that s is equal to 1 plus n times how many terms do we have? We have n number of terms divided by 2. And so this right here would be the formula for the sum of the first n natural numbers. Now, instead of having n, just to make it more concrete, I'm going to go over a smaller set. So let's say I go from 1 to 10. 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8, 9, 10. I go all the way. And I will do the same idea. So first I go forward, 1, 2, 3, and so on. Next I go backwards, 10, 9, 8, 7. And then I do the same idea. I add these two pieces, I add these two pieces, these two pieces, these two pieces, and so on. And so I would get 2s is equal to 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, and all of these pieces is equal to 11. How many 11s do we have? We have n number of terms. In our case, it's 10. You can simply count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I would get 2s is equal to 10 times 11. And if I want to just get s, the sum, I divide by 2, divide by 2. So 10 times 11 is 110. Divide by 2 is 55. And so our formula is correct. Now back to the problem at hand and the very famous example. So what is the sum of the first n natural numbers where we stop at 100? So 1, 2, 3, 4, 5, all the way to 100. And so we use that formula. S is equal to n times parentheses 1 plus n divided by 2. How many number of terms do we have? We have 100. So put 100 here, put 100 here, and we get 100 times 101 divided by 2, and we would get 5,050. And that's pretty much it for this video.